Welcome to Study Loop.
Hello everyone, today we're doing chapter 23, problem 70, and this problem asks us to synthesize each of these compounds from 3-pentanone, and we can use benzene and any organic alcohols that have less than 3 carbons. So let's begin with A. So let's start with this 3-pentanone. And we know that we need to add some sort of nucleophile, being nitrogen, onto the alpha position. So in order to do that, we need to make this alpha position electrophilic. So we need to brominate this alpha position, and we know how to do that by adding Br2 in acetic acid. So this will brominate or halogenate one of these alpha positions, making it electrophilic. And now we can make this nucleophile from some sort of alcohol. So we need 2 carbons, and then we can only start from alcohol, as the question stem states. So we need to make this alcohol into a strong leaving group. So then we can add ammonia to it to do an SN2 reaction. So we can make this into a better leaving group by adding PBr3 and then what will happen is that we're going to change this into bromine, and then at which point we can add ammonia to do an SN2 attack to make this into an NH2. So then we can take this and react it here to find or to yield our final product, which is this. Now for B, this is product A. So for B, we can actually take the product of A from this bromine position. We can take this product and add some sort of eliminating reagents to it. So lithium, CO3 with lithium bromide and DMF. And we know that this causes or this promotes elimination to occur. So we can get elimination occurring like this. And then all we need to do is just reduce this ketone into an alcohol using a mild reducing agent, sodium borohydride, in methanol. And this gives us product B. Now from C, we need to add this benzene ring, and we have 1, 2, 3, 4, 5 carbons. So we need to make this benzene ring into some sort of nucleophile, and then after that we can add that, or if we change this into an organometallic reagent, then we can add that onto this double bond using copper lithium. So if we do that, you'll see that if we start off with benzene, so if we start off with benzene, we can brominate this benzene position using bromine and some sort of Lewis acid. And now if I add lithium, copper iodine, then I would create copper lithium. This organometallic reagent, which acts as a nucleophile, and then I can take this reagent and react it with this product that I generated in B. So I can take that reagent, react it with this alkene, and then we're going to get addition on this, the least substituted side of the alkene, and we're going to reduce the alkene to an alkane in the process of doing that while adding this alkyl group here being this benzene ring to form product C. And now for D, we have 1, 2, 3, 4, 5, 6 carbons, and then the benzene and reducing it. So we actually need to first start with benzene for D and add an extra carbon. So what we need to do is Friedel-Crafts alkylation, but we can only start from organic alcohols, the question stem stated. So in order to do that, we need one carbon, so we'll start with methanol. And then we can change this alcohol to an halide, for example, by using Sokol. And then this gives us our alkyl halide that we can use with a Lewis acid, aluminum trichloride, to get Friedel-Crafts alkylation to occur. And we added an extra carbon bond. And now from this position, this carbon is actually at the allylic position. So if I add Br2 with lights, then we get bromination at the allylic positions. So now I have bromination at this allylic position, and once again, if I add lithium and copper iodine, then what I'm going to have is some sort of organic metallic reagent, but now I'm going to have extra carbon attached to it. And if I now react this with the same reagent that I did in C, you can see that I'm going to have alkylation here with the addition of an extra carbon. But now we need to reduce this using that mild reducing agent like we did in B to secondary alcohol, sodium borohydride and methanol. And we get that alcohol here.